To what degree, sticking on the topic of infinity, should we think of infinity as something real?
That's an excellent question. I mean, a huge part of the philosophy of mathematics is about this kind of question, that what is the nature of the existence of mathematical objects, including infinity. But I think asking about infinity specifically isn't that different than asking about the number 5? What does it mean for the number 5 to exist? What are the numbers really, right? This is maybe one of the fundamental questions of mathematical ontology. I mean, there's many different positions to take on the question of the nature of the existence of mathematical objects or abstract objects in general. And there's a certain kind of conversation that sometimes happens when you do that. And it goes something like this. Sometimes people find it problematic to talk about the existence of abstract objects such as numbers. And there seems to be a kind of wish that we could give an account of the existence of numbers or other mathematical objects or abstract objects that was more like, the existence of tables and chairs and rocks and so on. And so there seems to be this desire to reduce mathematical existence to something, that we can experience physically in the real world. But my attitude about this attempt is that it's very backward, I think, because I don't think we have such a clear existence of the nature of physical objects, actually. I mean, we all have experience about existing in the physical world, as we must, because we do exist in the physical world. But I don't know of any satisfactory account of what it means to exist physically. I mean, if I ask you, say, imagine, a certain kind of steam locomotive, and I describe the engineering of it and the weight of it and the nature of the gear linkages and I show you schematic drawings of the whole design and so on. And, we talk in detail about every single detailed aspect of this steam locomotive. But then suppose after all that conversation, I say, okay, now I would like you to tell me, what would it mean for it to exist physically? I mean, as opposed to just being an imaginary steam locomotive. And what could you possibly say about it? I mean, except by saying, I just mean that it exists in the physical world. But what does that mean? That's the question, right? It's not an answer to the question. That is the question. So I don't think that there's anything sensible that we can say about the nature of physical existence. It is a profound mystery. In fact, it becomes more and more mysterious the more physics we know. I mean, back in, say, Newtonian physics, then one had a picture of the nature of physical objects as, little billiard balls or something, or maybe they're infinitely divisible or something like that. Okay, but then this picture is upset with the atomic theory of matter, but then that picture is upset when we realize that the atoms actually can be split and consists of electrons and protons and neutrons and so on. But then that picture is upset when we realize that those things themselves are built out of quarks and leptons and so on, and who knows what's coming. And furthermore, all of those things, the nature of their existence is actually as wave functions in some cloud of probability and so on. And so it just becomes more and more and more mysterious the more we learn, and not at all clarifying. And so the nature of what it means to say that, there's an apple on my desk, and to give an account of what that physical existence really is at bottom, I think is totally absent. Whereas we do seem to have a much more satisfactory account of the nature of abstract existence. I mean, I can talk about the nature of the empty set. This is the predicate which is never true, or something like that. I can talk about those kind of logical properties, or the singleton of the empty set and so on. I mean, of course, it's very difficult if you go very far with it, but the point is that it doesn't get more and more mysterious the more that you say it becomes only more and more clear. And so it seems to me that we don't really have any understanding of what the physical world is as opposed to the abstract world. And it's the abstract world where existence is much more clear.
It is very true that we don't know anything about the soda bottle or the steam locomotive just because we can poke at it. Again, we anthropomorphize, and that's actually gets us into trouble sometimes, because I'm not feeling the quantum mechanics when I'm touching this.
That's right.
And therefore, it's easy to forget and feel like this is real and mathematical objects are not. But you're making the opposite argument. And you draw a distinction between numerals and numbers, which numerals are the representation of the number on the page and so on. But could you say that a number is real? Do numbers exist?
I happen to think so. I mean, I'm on the side of realism in mathematics, and I think that these abstract objects do have a real existence in a way that we can give an account of in a way I just tried to describe.
So, like, you would describe it as a size of a set
Well, there's
with 4
different
elements
ways
in
to
it.
understand the nature of 4. I mean, actually, this gets into the question of structuralism, which is maybe a good place to talk about it.
What is structuralism?
Structuralism is a philosophical position in mathematics, or the philosophy of mathematics, by which one emphasizes that what's important about mathematical objects is not what they're made out of or what their substance or essence is, but rather how they function in a mathematical structure. And so what I call the structuralist attitude in mathematics is that we should only care about our mathematical structures up to isomorphism. If I have a mathematical structure of a certain kind and I make an exact copy of it using different individuals as to form the elements of that structure, then the isomorphic copy is just as good mathematically, and there's no important mathematical difference that would ever arise from working with this isomorphic copy instead of the original structure. And so, therefore, that's another way of saying that the substance of individuals, in a mathematical structure is irrelevant with regard to any mathematical property of that structure. And so to ask a question like, what is the number 4 really, is an anti-structuralist thing, because if you have a structure, say the natural numbers, with all the numbers in it, 0, 1, 2, 3, 4, and so on, then I could replace the number 4 with something else, like, this bottle of water could play the role of the number 4 in that structure, and it would be isomorphic. And it wouldn't matter at all for any mathematical purpose to use this alternative mathematical system. That's to say that we don't care what the number 4 is really. That is irrelevant. The only thing that matters is, what are the properties of the number 4 in a given mathematical system, and recognizing that there are other isomorphic copies of that system, and the properties of that other system's number 4 are going to be identical to the properties of this system's number 4 with regard to any question that's important about the number 4. But those questions won't be about essence. So in a sense, structuralism, a kind of anti-essentialism in mathematics.
So is it fair to think of numbers as a kind of pointer to a deep underlying structure?
Yeah, I think so, because I guess part of the point of structuralism is that it doesn't make sense to consider mathematical objects or individuals in isolation. What's interesting and important about mathematical objects is how they interact with each other and how they behave in a system. And so maybe one wants to think about the structural role that the objects play, in a larger system, a larger structure. There's a famous question that Frege had asked, actually, when he was looking into the nature of numbers, because in his logicist program, right, he was trying to reduce all of mathematics to logic. And in that process, he was referring to the Cantor-Hume principle that, whenever two sets are equinumerous, then they have the same number of elements. I mean, if and only if. And he founded his theory of number on this principle. But he recognized that, well, there was something that dissatisfied him about that situation, which is that the Cantor-Hume principle does not seem to give you a criteria for which things are numbers. It only tells you a kind of identity criteria for when are two numbers equal to each other. Well, two numbers are equal just in case the sets of those sizes are equinumerous. So that's the criteria for number identity, but it's not a criteria for what is a number. And so this problem has become known as the Julius Caesar problem, because Frege said, we don't seem to have any way of telling from the Hume principle whether Julius Caesar is a number or not. So he's asking about the essence of number and whether, of course, one has the sense that he picked maybe what he was trying to present as a ridiculous example, because maybe you have the idea that, well, obviously Julius Caesar is not a number. And there's a lot of philosophical writing that seems to take that line also, that obviously the answer is that Julius Caesar is not a number. But the structuralists disagree with that position. The structuralist attitude is, look, you give me a number system. If Julius Caesar isn't a number, then I can just, let's take the number 17 out of that system and plug in Julius Caesar for that role. And now I've got a new number system. And now Julius Caesar happens to be the number 17. And that's totally fine. Yeah. So the point of structuralism is that the question of whether Julius Caesar a number or not is irrelevant to mathematics. It is irrelevant because it is not about structure. It's about this essence of the mathematical objects. So that's the structuralist criticism of Frege's point.
You've kind of made the case that you can say more concrete things about the existence of objects in mathematics than you can in our physical reality, about which to us human brains things are obvious and not. So what's more real? The reality we see with our eyes, or the reality we can express in mathematical theorems?
I'm not quite sure. I mean, I live entirely in the Platonic realm, and I don't really understand the physical universe at all. So I don't have strong views.
Let's talk about the Platonic realm. Is it, like, because you live there, is it real?
Or yeah, totally. Yeah. This is the realist position in mathematics, is that abstract objects have a real existence. And okay, what's meant by that is that there's some sense of existence in which those objects can be regarded as real.
How should we think about that? How should we try to visualize that? What does it mean to live amongst abstract objects?
Right.
Because life is finite. We're all afraid of death. We fall in love with other physical manifestations of objects.
Right.
And you're telling me that maybe reality actually exists elsewhere, and this is all just a projection.
Well, I mean,
from the abstract realm.
Do abstract objects exist in a place and at a time? That's very debatable, I think.
Right. And what does place and time mean?
Yeah. So
it's like, what's more real, physics or the mathematical Platonic space?
Well, the mathematical Platonic realm is, I'm not sure I would say it's more real, but I'm saying we understand the reality of it in a much deeper and more convincing way. I don't think we understand the nature of physical reality very well at all. And I think most people aren't even scratching the surface of the question as I intend to be asking it. So, obviously we understand physical reality. I mean, I knock on the table and so on, and we know all about what it's like to, have a birthday party or to drink a martini or whatever. And so we have a deep understanding of existing in the physical world. But maybe understanding is the wrong word. We have an experience of living in the world and riding bicycles and all those things. But I don't think we actually have an understanding at all. I mean, very, very little of the nature of physical existence. I think it's a profound mystery. Whereas I think that we do have something a little better of an understanding of the nature of mathematical existence and abstract existence. So that's how I would describe the point.
Somehow it feels like we're approaching some deep truth from different directions. And we just haven't traveled as far in the physics world as we have in the mathematical world.
Maybe I could hope that someone will give, the convincing account. But it seems to be a profound mystery to me. I can't even imagine what it would be like to give an account of physical existence.
Yeah, I wonder, like 1,000 years from now, as physics progresses, what this same conversation would look like.
Right. That would be quite interesting.